Glacial deposits. What's left behind after the ice melts? Well, depending on what part of the glacier you're dealing with, and of course, the majority of glacial sediment falls under the category of what is known as till. And unlike sediments deposited by streams or the wind or waves, till, glacial till, is unsorted. It's just a pile of every size of sediment: clay, silt, sand, pebbles, cobbles, boulders. Now, in a stream, or when the wind is blowing, sediments will be deposited in such a way that they're sorted based on the energy of the stream. Obviously, a slow-moving stream is only moving clay. And so when finally that clay is deposited, it will be a layer of clay, not a mixed layer of sand, silt, and clay, just clay. But if the stream is moving very quickly, it will be able to move larger pieces. And as the stream slows down, things drop out based on velocity. So it's the sediment is sorted. But in a glacier, that's not the way it works. It's neither sorted nor is it layered. Because imagine you have a situation where the stream is moving very slowly and you get a thick layer of clay over 200, 300, 500, 600 years, and then the velocity of the stream picks up and it's now only sand, silt, and clay that's deposited. And so on top of the clay, you have layers and layers of sand. So sorted and layered, that's not a glacier. And here's a picture of glacial till. Every type of sediment just all mixed together. We've got boulders, we've got cobbles, we've got pebbles, we've got sand, silt, and clay. Here we have it again, a beautiful cross-section of pebbles, cobbles, boulders, sand, silt, and clay, all together. Now, when you look down here, it's beginning to get sorted by gravity. Larger pieces are falling out of this exposed cliff of glacial till. But the till itself is a mixture of all sizes. This is also a very nice image of glacial till closer to the source of a glacier that might still be existing today. And you can see the angular pieces of bedrock that have been plucked from the ground beneath the glacier and picked up. Hold on, I gotta get cats. So, back I am. Cat break. So, moraines are the source of these unsorted sediments. After all the ice recedes, piles of unsorted sediment are deposited. A deposit of till is called a moraine, and there are several types. The terminal moraine, found at the point at which the great glacier grew to its maximum and then melts back, the terminal moraine, the last little bit of the glacier when it was at its furthest extent. Lateral moraines are the moraines that form at the side of, say, particularly a valley glacier, but it could happen with an ice sheet as well, a continental glacier, pushing through rock that is higher than the ice and then receding and then leaving lateral glaciers, lateral deposits of unsorted sediment. And then the medial, where maybe two glacial streams or rivers of ice meet. And here you can see the terminus, the end point of the glacier, terminal moraine. Now the outwash plain is deposited sediments too, but these are being moved by water or wind, so they're sorted. But this is not sorted, not sorted, not sorted. None of these deposits in the medial moraines or the lateral moraines are sorted. They are unsorted glacial till. Here's a picture of the medial moraine and some lateral moraine. Unsorted sediment. Ronkonkoma and Harbor Hill terminal moraines are found on Long Island, Staten Island, and they extend through the bottom of the ocean and pick up again Martha's Vineyard and Nantucket. These are all glacial deposits. Long Island is one big glacial deposit. The South Shore, more of an area where sediment from the moraine washed out. And if you could lower sea level, you would see lots of sediment that had been washed out from the glacier. And along the landscape here, we can see little bits of moraine in Connecticut, Rhode Island, and into Massachusetts. And then this moraine, this end point of the last glaciation in the Wisconsin, cuts up to the northwest. Again, the Harbor Hill moraine and the Ronkonkoma moraine, the only areas of Long Island that are really very high, right? And back here, hillier, where the pile of sand stopped, than down here where sediment has been washed out but still is above sea level. And again, our glacial confluence, the point of the glacier's meeting, is where we see a medial moraine, and then we have lateral deposition, and all of this gray is sediment that, if this glacier retreats, will be deposited. Now, of course, there's always water moving under a glacier, so water that moves under a glacier will move sediment, and that can be sorted as it leaves the glacier by erosion due to water. So here's your unsorted glacial, every deposition, every type size of sediment represented. Then the glacial sediment has been sorted by wave action. So the waves have moved and then redeposited what had been originally a glacial deposit of unsorted material. And then finally, even more sorting by higher energy waves. So these waves are strong enough that over 5,000, 10,000 years, these beaches have formed, and the sediment is sorted based on the energy of the waves. This is what our area looked like at the time of glacial maximum. So here's that moraine, right, stretching across the beginning of Long Island here through what's then Staten Island. And this would be the outwash plain. This was above the sea. Sea level was much lower. You can see tundra and wetlands, very cold, right? This is upland area. And then if you put it together with our current map, you see that New Jersey is a huge area of glacial outwash. The light orange is glacial outwash on Long Island. And again, these humps of gray are where the moraine was, the glacial maximum. And often when glaciers retreat, they leave behind lakes that form when ice presses down on the land and depresses it into a concave bowl shape. And over time, ice sitting on top will lose some sediment, and the clay will settle on the bottom of that depression, clay sediments and silt sediments, and that can seal. Clay is a really good sealer for a pond or a lake. And now the glacier is left far behind, but it's still, water is still flowing, say from a river of ice water, down into this newly formed glacial lake. And again, we see that when we talk about the Great Lakes and the Finger Lakes in New York. Here's this is from the review book, just some basic glacial forms. You have what are called kettle lakes, these lakes left behind, formed by ice that was left behind and created depressions that were then filled with water and sealed with clay. The esker, the stream that's running under the glacier moving sediments. You'll have sorted sediments along the esker, but here at the terminal moraine, no sorting here. Slightly sorted in the Kame, unsorted in the drumlin. Now drumlins are really important because they help us figure out which way the glacier moved forward and back. And let's see if we can figure out why that is. Now, Kames often are related to kettle ponds that form. So as this area melts back, you'll get a depression here, a kettle pond forms, and then on either side of the kettle pond, you can have a hill of sediment, which becomes what is known as a kame. But first, our drumlin. The drumlin shows the direction of advance and retreat. So to the right, the glacier advanced. The glacier came down, hit some bedrock, got slowed down, deposited a lot of sediment here, made a pile of it, then speeds up, moves up, and slowly returns to its normal rate of forward motion. Then as it comes back, retreating back, it grinds down, pull and erodes some sediment here, and then this sharp edge remains from the initial deposition. So here we have the drumlin. Again, steep slope is where the glacial front got slowed down by bedrock. Deposition, glacial till, unsorted, and this overall structure indicates to you by looking at it which way the glacier advanced and retreated. That's kind of amazing that you can just tell from the landscape, and you can see it here so clearly on these maps. All of these little forms are drumlins, and you see they're high on one end, high on one end, high on one end, high on one end, all high on one end, lower on the other, lower on the opposite end, and they're all giving you an orientation in terms of how the glacier advanced and retreated, advanced and retreated. And this is an area up near the Finger Lakes in New York. Here's your Kame and Kettle ponds. So you have ice, 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 ice. You have a crevasse, you have ice breaking off. Then you have sediment that are filled with, at first, ice, which melts and eventually becomes a pond. So here's your Kettle Lake, and in between are piles of sediment that got left behind. Piles of sediment left behind in between these Kettle Lakes or ponds. And you see this when you look out on the western landscape over Minnesota, parts of Wisconsin. You see what are called prairie potholes, hundreds and hundreds of lakes which have been formed by the retreat, advance and retreat of a glacier. And of course here we have our Great Lakes, which are the result of our last several glaciations going back several million years. The Wisconsinan, Illinoisan, Kansan, Nebraskan, all these going back as far as about 3 million years. So the ice carves these depressions and then leaves behind vast amount of water, melts, but then the annual rates of precipitation north of the lakes and west of the lakes feed the lakes, and the elevation is going down from Lake Superior to Lake Michigan to Lake Huron to Lake Erie to Lake Ontario. And here you see the Finger Lakes, and a lot of these lakes in this area around the Great Lakes have been formed by the advance and retreat of our last glaciation. Here is a close-up of the Finger Lakes. Now, the Finger Lakes are interesting because this is, if we remember page 2 of our reference table, we know this is the Alleghenian Plateau, a region of high elevation compared to the area here, the Erie lowlands near the lake. And the glacier receded to the north towards the lake, and it left behind sediment that dammed up a depression dug out by the glacier. That dam allowed the water to stay, but eventually streams develop that flow out of these Finger Lakes to the north because the water is moving from a higher elevation on the plateau to a lower elevation at the lake. So these are our Finger Lakes formed by the last glaciation. The last part of glacial deposition are glacial erratics. These are rocks transported tens to hundreds of miles by glaciers and whose mineralogy doesn't match exactly the mineralogy of the underlying bedrock. So if we go to Central Park, we see this. Here we have Manhattan schist. This rock was left behind by a glacier 11,500 years ago. It doesn't match the bedrock below it. This is a glacial erratic. Just a little bit north of this picture, another glacial erratic left behind on the Manhattan schist or Heartland schist bedrock down in this region of the park. This is down in the 60s. This is not the same rock at all. Or here in the Sheep Meadow. This is a metamorphic rock, but I believe this is a gneiss, whereas what's the bedrock here is a schist. And so this rock likewise deposited by a retreating glacier. This was a very sad little moment, because the second after I took this picture, this little boy just like threw himself off this rock and landed here like a sack of potatoes. He cried a lot, but I think he was okay. I didn't stay too long. His parents were there, and lots of people were there to help. Here's a really big erratic in Wisconsin. It's just a gigantic erratic. So this left behind by a glacier. The general rule with glaciation is that except in KAMES and along outwash plains and eskers, glacial sediments are unsorted. But sediments deposited by streams, rivers, waves, and wind are sorted. And with that, we're going to stop this segment.